have to do with that formula n equals little m over big M. Okay? We're going to add on to that a little bit today. We're going to talk about molecules as well. Now, this is a thing that we've done in Science 10. Again, could have been a while ago, so we're going to review it because that's what we do here. And then once we get this done, we're probably good for all the review stuff that we're going to need for this unit. Okay? But I do want you to copy this down real quick, just so you understand. This is kind of what we're doing as far as the progression goes. So you can kind of keep. Oh, I guess I have a sheet for you guys today. Let me get that for you. So, like I said, last day we talked about getting from mass to amount kind of thing. If we had the mass, we can get to amount. Yep. Somewhere, wherever you want. Do it on the back of that sheet if you want or whatever. And then today we're going to go from mass to amount to perhaps something called molecules. Okay. Now, it doesn't have to be molecules. There's other words that we could use there. It just kind of depends on what the question's asking. So it could be atoms. If you remember in Science 10, we talked about something called formula units, which is like the ionic compound version of molecules. Usually we just say molecules from now on, but whatever, it doesn't matter. How do I get from mass to amount? I use this formula here. Mass and molar mass. So basically, we know that the mass is usually measured in some kind of form, like usually grams. Okay? So if I had the grams, the 25 grams or something like that, I could say that's the mass. And that would get me into moles, amount, right? Now, this part is going to be a little bit of review here. How do I get from moles to molecules? Yeah. Big one. Yeah. Which is 1 mole always means 6.02 times 10 to the 23. Okay? And again, over here, I already kind of put molecules here, but you know, maybe I should have just left that blank or whatever, but basically we're kind of talking about how do you get from grams to moles to molecules, or vice versa. Okay? So if I'm in, like I said, between these two here, mass and amount, I'm going to do that formula. And between amount and molecules, I'm going to use this ratio. It's not really a formula, of course, but there's no variables there. But I'm going to use that ratio to help me get to the next part. Okay? So that's kind of what you're going to use in between these. Okay? Now, 1 mole. Again, we talked about this before. Well, maybe in Science 10 again, I don't know, but you know, it's the same as saying this kind of thing. Like if we had a dozen eggs, or let's say 1 dozen, I could say, well, there's 12 eggs in this carton, right? So 1 dozen would be 12 eggs. But a dozen, 1 dozen, could also be 12, well, donuts, right? So if I went to Tim Hortons and I said, hey, give me a dozen donuts, well, then I'd be putting a dozen donuts there, or 12 donuts, I should say. And if I said, hey, let's go count out a dozen cars in the parking lot, well, I'd have a dozen is 12 cars, right? So the point I'm trying to make is this part here could change. Okay, it could be atoms, it could be molecules, it could be ions, it could be molecules, it could be formula units, it could be whatever compounds, it could be particles, it could be whatever you want it to be. Depends on what the question's asking you. Okay, so usually in this case here, I would probably say molecules. Okay, but again, you can have a mole of anything. All right, it doesn't make sense for a lot of things. Like if I said, you know, one of the things that we do in Science 10, if you remember that, is we talk about a mole of pennies. Well, if you stacked a mole of pennies, if you took that many pennies, 6.02 times 10 to the 23 pennies, or 602 sextillion pennies, and stacked them on top of each other, it would reach the sun and back to Earth 4 million times. That's how many pennies you'd have. That's a lot of pennies. That's a big distance. So we could talk about a mole of pennies. It doesn't really make sense. We could talk about a mole of cars. I don't think there's that many in the world. Okay, so it doesn't really make sense. We could talk about a mole of a lot of things. We could talk about a mole of people. Doesn't exist. Okay, but when we're talking about really, really small things, this is how many things we need. A mole, we need 6.02 times 10 to the 23 to even be able to weigh some of this stuff. That's how incredibly tiny these atoms are and these molecules. So that's where that kind of comes from. So when I say a mole, it's like saying 6.02 times 10 to the 23. Okay? So the key here is this. We've done this part already. We've gone from here to here and back. We did this. Okay? That was the homework. That was questions 1, 2, and 3 on the back side, yes, roughly. Not maybe 3, that was the molar mass, but we've gone back and forth between these. So today, what we're going to do is that, plus we're going to add this in as well. Okay? So we're going to go between these two things. And the key here is this. You always have to go through the middleman. I call him the middleman. The middleman is the mole. Okay? You have to, if you want to get from mass to molecules, you've got to find moles first. So we go from mass to moles to molecules. Okay? Or vice versa. Molecules, moles, mass. Okay? You always have to go through the middleman. And again, some questions you're not going to have to do all that. Some questions are you're going to start here and you're going to end up here. Okay? Fine. Sometimes you're going to start here and you're going to end up there. And that's fine too. Okay? Or maybe you got to go from here to here. Done. Okay? But it depends on the questions, of course. All right? And I know for a fact, I don't know about your class, but I know in Science 10, okay, whatever class you're in, whether it's AP or regular Science 10, in my class, this is the back page of the test. I just gave it the other day. The back page is convert this mass into moles, convert this moles into mass, convert molar mass or this mass into molecules. If I this molecules, how many with the mass? So I know that this is usually the back page on that first unit chemistry test in Science 10. Okay, but here we go. Our first example looks a little something like this here. Oh, no, I lied. Looks like a little something like this here. It says, we kind of talked about all the other stuff there, but if you find this example, I think it's the first example. It says, I know this is really tiny, but you guys have it there as well. It says, how many molecules of carbon tetrafluoride are in a 75-gram sample? What's a 75-gram sample? What does that tell you? What variable or what is that basically saying to you? When you see 75 grams, it's what? Somebody, anyone, come on. Yeah, mass, right? Little m. So there's my little m. Good enough. Okay? Carbon tetrafluoride. What do I know about carbon tetrafluoride? Can I find a formula for that? Yeah. Okay. It is CF4, isn't it? Carbon tetrafluoride. What else can I find from carbon tetrafluoride then? What else? Somebody else? Huh? Molar mass. Big M. So what do I need? I need a carbon and 4 fluorines, yes? And 4 fluorines works out to be what? 1938, double that is 76. And then a carbon is 12.01, so what? 88.01 molar mass. Okay? 88.01. So now, I already have 2 numbers here, don't I? And already things are moving along. So I think to myself, okay, really, I had this, the mass, right? And I want to get to this. How many molecules? So again, if you struggle with this stuff and if you're not sure what is the question asking me and stuff, then you really need to take note of this. Yes? Because this is going to be your little roadmap here that you're going to use to say, okay, they're giving me this, the mass, 75 grams, that's where I am. And I need to get to here to molecules, yes? And to get to molecules, I got to go through moles. He's the middleman. Okay, there's no skipping around the middleman. So, to get from mass to amount, I'm going to use this formula right here. N equals little m over big M. And hopefully, we have enough information for that. And if I go back to here, I do. I have N equals little m over big M. I have 75 gram sample. I have 88.01 grams per mole. How about this? Look at this. I have 2 pieces of information. Okay, I started with 1. I found the other number. And I got these 2, and I divide the 2, and I got N. I'm at an amount, right? And when I divide those 2, and I believe, there we go, I get 75 divided by 88. 0.01, 0.852. Moles. Okay? And again, I will caution you, make sure you're answering the questions. If the question says, what amount do you have of carbon tetrafluoride, or how many moles do you have, you're done. It doesn't say that. It says how many molecules. So again, looking at our little chart here, now you went from mass, you are now at N, amount, moles, right? I just found 0.852 moles. Now, how do I get to molecules? Well, I'm going to use this little ratio thing here, right? So what does that look like? Well, I'd say, well, let's take a look here. So 0.852 moles. By the way, I put the little dots there in case you, I don't know if I've done this before for you or not, or maybe somebody else has, I don't know, but I put dots there just to say that this number keeps going for a while. And I don't care what the number is, to be honest, because that's on my calculator. So I just say, you can just put 0.852, that's fine too, but the dots just basically imply that I'm not rounding this. This is the number, it's on my calculator, and I'll use that, okay? So it's 0.852, yada, 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 whatever, da-da-da, okay? Now, I'm going to show you two different ways to do this. Up to you, okay? If you're good at math, you probably don't need to pay attention. You can go back to bed, okay? If you're not, you got two options, okay? So at this point, I have my ratio of 1 mole and 6.02 times 10 to the 23 molecules. And if you know how things work, I would say I put the mole here so that 1 mole and mole can cancel. Yes? That makes sense. And then I'd put the 6.02 times 10 to the 23 molecules here. Okay? And basically what I'm saying is, hey, look, 1 mole of 6.02. 0.85 would be 0.85 of that 6.02, right? That's one way to think of it. Something you can do there. Okay, now this isn't the only thing you can do. I'll show you another option. But of course, when you do this, you're just going to type this in on the old calculator here. There's my number right there. It's still there, right? That's what I'm saying. This is not, it's not 0.852, it's this number. We do not round until I give you my final answer. Then I'm going to type in times 6.02 times 10 to the 23. Now, I don't know if you guys know, so I apologize, but I don't know if you know how to enter this on the calculator, or maybe if you know all the little tricks or not. I don't know, but you can go times 10 to the 23. That's an option. Okay? And I don't know if that's what you do or not. I don't know, is that what you guys do or not? That's an option. No. Okay? That's fine. Nothing wrong with that. Do what you got to do. There's also, you could do this, 6.02, and I go second E. Maybe you guys use that. Okay. That's probably better. Okay, and I'll tell you why. But there's you got options. Okay. There's probably even a different way to enter it in. You could probably do times 10, and there might be like a Y. Oh, right here. You could use that probably as well, I think, like that 10x thing there. You could probably do that. There's probably like a couple options you can use. But if you use the E, it works out pretty well. The E means times 10 to the power of 23. Okay. Now, do not put E and then put another 10 in there or times 10 or something. No. E means times 10 to the power of, then you just put the exponent. Okay. Basically, the E means exponent 23 with a base of 10. That's what it means. Okay. And when you type that in, you'll get 5.13, 3 significant digits right there, times 10 to the 23 molecules. Okay. Now, this is where you round. Okay. I need 3 significant digits. There's 3. Okay, no more dots now. Now that's my final answer. You round that last number depending on what you need to do. Okay, yeah. Okay? That's where you round. Final answer.
Final answer is
5.13 times 10 to the 23. Okay? Again, there's other options. I'm not going to tell you what to do because I don't know. Maybe you got a different option than one of these two. I don't know. Okay? Ultimately, we're probably doing the same thing. I mean, if you're getting the right answers, you're probably doing the same thing. As long as you understand what you're doing, that's all I care about. Last option I'll give you is this. Instead of doing this part right here, if you got the number of moles, which is 0.852, so we got that from the question. So before I even get to that, I'd say, okay, 1 mole is always 6.02 times 10 to the 23. In this case, we're talking about molecules, so I'll put that down. Molecules. Okay. You could set up an equivalent fraction. Okay, so you could set up like what they call, we used to call back in the day, ratio proportion, basically a proportional fraction. Now they call it equivalent fractions, if you've heard of that term, yes? Equivalent fractions. So they're saying if 1 mole is 6.02, 2 moles would be twice as much, half a mole is half as much, etc. Well, what's 0.852 moles? How many molecules would that be? And you could cross multiply and solve or whatever. It's up to you. Okay? So again, 1 times x is x. 6.02, oopsies, or this number here, whatever, 0.852 moles times 6.02 times 10 to the 23 molecules. Okay? And you multiply that out, and you get 5.13 times 10 to the 23 molecules. I'm missing a moles over here. This mole would cancel out with that mole, and you'd be left with molecules, of course. Okay? So that's an option too. You could cross multiply, set up equivalent fractions. That's an option. Either way, you should get the same answer, but it's up to you. Okay? I don't know. If you need help with that, come and see me. Okay? We're going to be doing this for a while, so I can find you some practice questions, etc., etc. Okay? Yep. Yep. Good. Okay. Now, quite often, we're going to work backwards too. So we're going to start maybe here and go to here, and maybe we're done there, or maybe we got to go back to here. So we're going to do one more example backwards, and I'll give you some time to work on some stuff. Now, the one that we need to find, they're not quite in order here, so just be aware of this. This is the third example. So we did 1, we're going to skip 2, we're going to go to 3. And it says this, calculate the mass. And then I have 6.52 times 10 to the 24 molecules of water. And water... water looks like that, H2O. And we have a molar mass there, yes? 18.02. Again, 2 hydrogens and an oxygen, 16 and 2.02. 18.02, yeah? So, again, I want to find the mass. I'm starting at molecules. So if I'm starting at molecules, again, I'm starting here, and I got to go to here. And to get from here to there, I'm going to use this ratio right here, okay? Now, however you wish to do that, you can set up the equivalent ratios again, whatever. You can multiply one by the other, whatever you want to do. I'm going to start with 6.52 times 10 to the 24 molecules. And I'll just do this part again here. I think I'll do it this way, but if you want me to do it the other way, I can do that too. Now remember, what's the goal here? Well, I have 6.52 times 10 to the 24 molecules. That's a really big number, right? And I want to get it something reasonable. I want to get the amount. What's that equivalent to an amount? How many moles is that, right? So I'm going to put the 1 mole here this time. So I'm going to take this ratio and I might flip it over, right? So 1 mole is going to go on the top. 6.02 times 10 to the 23 molecules goes on the bottom. And again, I can't stress this enough. Look, in numbers, the 1 mole is always 1 mole. So 1, if you're going to write down 1 here, that's the mole, 1 mole. Okay? That always goes together. 1 mole always goes together. 6.02 times 10 to the 23 particles, molecules, atoms, whatever, that always goes together. Okay? And you want to arrange it so that molecules cancels with molecules, right? The top part cancels with the bottom part. Okay? Look, if those two cancel, what are you left with? You're left with moles, right? Which is what we want. We want to get the amount. We want to get to the middle guy, right? So we want to get the middle guy. When I divide these two, basically I'm going to take this number times 1, which is that number, divided by 6.02 times 10 to the 23. Now, calculator time. Go ahead and do that for me real quick. Let's take a break here. 6.52, you got that on your sheet there, times 10 to the 24, divided by 6.02. And what do you get as an answer? Somebody? 10.8. Yeah. If you do not, then you didn't type it in properly. Okay? So this is what we need to be careful of here. And there's a couple options. If you're going to do this, I'm assuming that's what you did if you did not get 10.8. So if you're going to do this, that's fine. But you have to make sure, like you might say, well, the calculator gave me this answer. Well, it did, but that's how you typed it in. So it gave you the right answer, but not based on what we wanted to do. This right now will take 6.52 times 10 to the 24. Great, that's what we want. Divided by 6.02. Okay. It'll do that next. Then take that answer and times it by 10 to the 23. Now, if you typed it in like that, you're going to get the wrong answer because we need to take the top number divided by the entire bottom number. Right now, if you type it in like this, you're taking the top number divided by this 6.02, then getting your answer, then timesing it by 10 to the 23. You're not doing the right order of operation there. Okay? The calculator is, because that's what you typed in. If you ever see this, E47, E48, E49, E50, E46, just mark it wrong yourself so I don't have to. Or, better yet, fix it. Okay? I'd rather you just fixed it, actually.
How do you fix it?
I'll tell you. Because that E47, anything around E47, you ever take a little bit there, is impossible. Okay? I mean, E to the 23 is already a big stretch. That's ridiculous. Now, it's 602 sextillion. Okay? That's a stupid big number. E47 is like 45 zeros. It would take up the entire board. Okay? I can't even, I don't even know. Like there's nothing that we can't, that's not even a countable number. Like that's not a legit number. This is basically times 10 to the 23 is almost not legit, you know? So that's not an option. How do you fix it? Well, if you're going to do this, you're going to need brackets. Like that. Then you're taking the number divided by the number, you know, not this number and times this. It's number divided by number. So this works. You might say, do I need brackets in the first part? If you're not sure, put them there. You know, you don't, but 10.8. Okay, that's option 1. If you know how to use the E button, I strongly suggest you do that, because then you don't have to worry about forgetting brackets. So 6.52, this is your other option. If you want to write this down, anything, that means times 10 to the 24. Okay. Divided by, don't need brackets. And the reason you don't need brackets is because the calculator knows that when you type it like this, this is the calculator programming kind of thing that it does, right? Texas Instruments says, hey, if you put an E there, the calculator is going to know it's times 10 to the 24, and that's one number. We want to take that number, and we want to divide it by 6.02 E23 times 10 to the 23, that number. Okay? And that's the way the calculator does it. And if you remember, the calculator uses the E for times 10, right? So if you do this, that's fine too, 10.83. Okay? You have to be super careful of that. And again, you can't, when you get in these numbers, you got to make sure that they make sense. Look, let me just do this real quick as well. Let me just write this down. It was what, 10.8? Is that right? 10.8 moles roughly, yeah? Now, actually, let's finish this off and then we'll go back. So 10.8 moles, I'm looking for the mass. So, you guys did this last day. If I'm looking for the mass, I'm going to rearrange it. Get that. Okay. Multiply both sides by big M, cross that out, etc., etc. I get that. And look, I have 10.8 moles times the molar mass, 18.02 grams per mole. If you remember way back in the beginning here of the question, it was water, 18.02. Okay. Multiply those two together, and I believe, help me out here, I'm pretty sure it's 195 grams. All said and done, 3 significant digits. Okay? And that would be your final answer, calculating the mass. Okay? You good? I'm just going to write something down here real quick and then I'll be done. Look, that's how we get the moles, yes? Correct? It's that number divided by that number. It has to make sense, okay? Look, if you're taking, look, you can divide, if you had 3 times 4 divided by 2 times 5, okay, let's say, I don't know, whatever. I guess I could have made it easier, but you can divide this, 3 divided by 2, right? You could do that, and then you could do this, and you could multiply those 2 parts together, right? It doesn't really matter. I mean, you could do that if you wanted to. But what I'm saying here is, look, if you just focus on this part for a second here. If you took 6.52 and divided by 6.02, give me a ballpark. What is that roughly, as far as numbers go? Don't even need a calc. What's 6.5 divided by 6, roughly? Be as general as you want. 1. So go with 1, right? Yeah? It's probably 1-ish. Yeah, 1 and a bit. They're almost the same number, for crying out loud. So it's about 1-ish. Yes? You guys know, or should know, how to divide powers, right, with the same base. What happens when you have 10 to the 24 and 10 to the 23? You get what as the difference? 10 to the 1, yes? You subtract the powers, yes? The exponents. They got the same base, 10 to the 24 divided by 10 to the 23. You subtract those. So that's 10 to the 1. What's 1 times 10 to the 1? What's 1 times 10? 10-ish, yes? So your answer should be 10-ish, which is 10.8 in this case, apparently. Good enough, right? But if you're dividing these two, if you take this number and you divide this number and you get times 10 to the 47, how do you take a big number and divide it by a big number and get an even bigger number? It'd be like taking, I got $1,000, and I'm going to divide it by 900, okay? $1,000. I'm going to divide it by the 900 students that go here, and I'm going to get $1 billion. That's what you're basically doing, right? You're like, that's amazing. I'd be doing that. Trust me. That's the kind of rationale that this is. A big number divided by a big number is an even bigger number. If anything, it should be like a logical number. Okay? So, that's kind of the same deal, right? So, just kind of keep that in mind.